Welcome to the first webinar of this series. It's an IEA EBC Annex 80 webinar on resilient cooling, organized by INIVE in cooperation with AIVC and venticool. My name is Philipp Stern. I'm here on behalf of the operating agent of Annex 80, Peter Holzer, and I will guide you through this webinar. So, as I already mentioned, this is the first of a series of 4 webinars, which we conceptualized with INIVE, AIVC, and venticool. It will be on indicators to assess resilience of cooling in buildings, and we will have another webinar at the end of the month on future weather data and heat waves, which will begin 1 hour later than today, as we have our friends from the US and we don't want them to get up so early. So it will start at 4 on the 31st of May. So this is today's program. As already mentioned, I'm here on behalf of Peter Holzer. I will give you a short introduction on the Annex 80. Then I will give you a brief overview of definitions of resilient cooling of buildings and an overview of indicators. Then we have our colleague Mohamed Hamdi from the NTNU in Norway, who will speak more about these specific indicators and benchmarking. And then Abdelaziz from the National Research Council of Canada. He will talk about the application of these indicators and vulnerable buildings. And then at the end, we have our questions and answers session. We will try to be punctual and finish at 4:15. So my presentation consists of 2 parts. So first, a short introduction to the Annex and the state of the project of this multi-year research project, and then definitions of resilient cooling. So first, what is the Annex? And mostly important, the Annex is what the institutions and the members that participate. So we have 36 institutions from several continents all over the world. And we also have 2 guests because they are not part of the EBC, this technical collaboration program of the IEA yet, from Mexico and India. So this is how the plan of the project went. So we had 1 year of preparation phase. We are now at the end of the working phase, entering the reporting phase, but due to some time lag, or how to say, like we couldn't do metering during the pandemic, so the working phase will eventually go on until the end of the year, but we try to finish the project by the end of June in 2023, so next year. This is briefly the roadmap. We can see we are already entering the reporting phase. On the top right, you can see what we promised the executive committee of the EBC. These are our deliverables, which we will deliver at the end of the Annex, and we are still already working on. So what is the objective of Annex 80? And this wasn't a very easy task to define, but we came up and said, okay, it should support the transition to an environment where affordable, low energy and low carbon cooling solutions are the mainstream and preferred solutions for cooling and overheating issues in buildings. So it's a very broad approach. And then we defined in 4 categories or 4 sub tasks, different objectives. So first, we wanted to assess benefits, potential, and performance indicators, and then provide guidance on design and performance calculation. We also want to carry out research towards implementation and of emerging technologies, so extending the boundaries of existing solutions. We believe that there are already very good solutions out there, but that they experience specific boundaries, especially when it comes to future scenarios and disruptive events, but I will come to that a bit later. Of course, we want to evaluate the real performance of resilient cooling solutions, and finally develop also recommendations for policy actions. This is also a very important task in IEA projects. So, and then we structured our Annex in these 4 subtasks, as mentioned already: fundamental, solutions, field studies, and policy actions. And I will now quickly go through the subtasks. I won't go into very detailed, but just to give you an overview. So here, what is very important is the definition of key performance indicators, and then at the end, a composition of design and operation guidelines for resilient cooling, and the definition of resilient cooling itself, which I will come to in my second part of the presentation. So again, starting from a very broad perspective, what is resilient cooling? So we at the beginning said, yeah, it's should be affordable, of course. Yeah, should be low energy and low carbon cooling solutions. It should somehow also strengthen the ability of individuals and communities, so have a very broad impact on the whole. And what is it against? So like the resilience against what? So to withstand and prevent thermal and other impacts of changes in global and local climates. So again, a very broad definition, but we had to start somewhere, and it tried to take every aspect into consideration. We then, as this is a very technology-based research group, grouped our technologies in 4 groups. So the first group, to reduce heat loads to people and indoor environments. Remove first is like solar shading, for instance, or cool coatings. Then remove sensible heat from indoor environments, like classic cooling, refrigeration, or ventilative cooling, for instance. Enhance personal comfort apart from space cooling. So this is a pretty new field, and there's also a new annex just being started now. So very small devices that only cool the personal environment and not the whole space, like fans or other small devices. And then remove heat from latent heat from indoor environment, like desiccant cooling or dehumidification. And first, what we did a technology review. This was in Subtask B. So as I already mentioned, these 4 technology groups. This is an extensive list of technologies we assessed, and which outcomes fed into the SOTA, the state-of-the-art report. So as you can see, the lists are sometimes long, sometimes short, as there is not so much new or like so many technologies in this field. And the technologies in bold are these ones which we're really assessing in our technology assessment at the moment. So this the objective of Subtask B to assess the technologies in future weather scenarios and extend the range of resilient cooling systems, and for the successful implementation of such technologies, and then in the end come up with concise technology profile sheets so that we have a description of these technologies and have a comparable base for these technologies, which could be easily said, but it's a very difficult task to find a set of key performance indicators that you can compare all these technologies with. As already mentioned, field studies, I won't go into detail here. You can see we have 19 field studies, and you can also see that we have some very well represented technologies like ventilative cooling, adiabatic cooling, but there are also some gaps, some technologies which are not assessed so frequently and so often. But this is just how the group consists And finally, Subtask D, the policy actions, where we now we carried out a policy collection. We reviewed these policies, and we are now coming up with recommendations and writing a report to hand over to stakeholders and politicians. This is the summary of the deliverables, where you can see who is it addressed to and which subtask is responsible, but I'm not going into detail here. We have already published several publications on the topic of resilience and the definition and the resilient cooling strategies. There are some more to come, and we can make they are freely available, so we will send this out, this list.